This guy is back in with an interesting problem, and this one uses, well, invariance. So let's have a read. The numbers 1, 2 up until 9 are written on the board. Just write that out. A move replaces two numbers AB by the single number AB plus A plus B. After 8 moves, one number n remains. Find n. Alright, let's start picking out bits from information. So we do a move, and that replaces the two numbers, so let's say 1 and 2, by AB plus A plus B. Now we do this 8 times, but notice how there's 9 numbers. So we can use this new number formed to do with 3. We form another new number, we'll go with 4, and so on and so forth. We just keep applying the same move. Now at the end, what we'll get 1, 2, 3, 4, 5, 6, 7, 8. So these are all just pairs. Alright, okay, so that's how we know where these 8 moves comes from. And after 8 moves, one number n remains. Find n. Well, So essentially what we're saying is we put these numbers into a formula, right? Into this function, get an output, and using that output, put these two into that same formula, go again, and go again. But if we were to do this by brute force, this would take ages, and this is where the invariance would come in. Notice what would happen if we add just plus 1 to each term of the numbers 1 to 9. So now we've got 2 to tell. And you might think, why do we do that? Well, check out what happens if we add this same one to this property we've got here. AB plus A plus B plus 1, which factorizes to A plus 1, B plus 1. And essentially this is A and B are just numbers picked out from this list of numbers here. So A1 plus B1 are just the product of plus 1 on any of these numbers, so 2, 3, up until 10. So then we can say, using this, the product of all these numbers, so our shifted list, let's say, remains, well, just the same, invariant. Now, we can sort of see the problem as applying the move, well, to these numbers. Well, let's call this, this new list, P, or this new problem we're solving. Let's say P equals what we've got. Let's actually write out like this: 1 plus 1, 2 plus 1, 3 plus 1, and so on and so forth up to 9 plus 1. So essentially what we're doing is 1 plus 1, those are these two numbers times by each other. And since the new function, or the new move that we're applying is A1 plus B1, A plus 1 times B plus 1, we can use like the product of 2 and 3, which is 6, and times it by 4, use the product of that and times it by 5. So that's what the new rule allows us to do. We can just multiply, and we've got our move applied. So let's go ahead and do that. So 1 plus 1 times 2 plus 1, which is 3, times 3 plus 1, up until 9 plus 1, which is equal to P, 2 times 3 times 4 times 5 up until 10, which is the same as just 10 factorial. Now, the issue was that the question, well, was asking what happens when we apply AB plus A plus B and plus 1. Well, we want just AB plus A plus B, So all we have to do is we can write P as A, B plus B plus 1. P minus 1 equals A, B plus B. So therefore, that equals 10 factorial minus 1. So essentially, after we've applied the 8 moves, only one number remains, whichever way you apply the moves, whether you go 1 times 3 first, 1 times 2, or 1 times 9, only one number n is left. And because the product of all these numbers here that were shifted is invariant, that's why we just sort of conclude that this must equal P. So then after we've calculated for P, we just subtract 1, and we've answered the question we've answered what was given to us, find n. So, not bad. You should say that was n, that was our n. Not bad at all. Hard problem, but it was nice. I used a bit of invariance, which isn't quite commonly used within TeamUA, but it can come up, so good stuff. Right, see you in another video. Goodbye.